This is the entrance where we process copper ore to copper metal. This is Mr. Tumbo. He will explain the process. He's a chemist who is an hydrometallurgist. My name is Alphonse Kiley. I'm a mining engineer myself.
As Tumbo, we are doing here metallurgy, processing copper ore to copper metal. This is the ore. After mining and bringing it to the factory, we bring it into this form. We reduce it into size. After crushing it to small pellets, we put it in these containers. These are barrels, 12 of them. The barrels, we put about 100 kilos in each of them, and then we add in sulfuric acid, 10%, which is about 180 grams per liter. That one and the copper ore itself is 8%. So when the reaction is taking place there, now we are leaching. After leaching, we filter the copper sulfate. When it is very clear, then we put it into a solvent extract, which is we are using Mextro type for purifying or attracting the copper. That is now solvent extraction stage. Leaching stage, solvent extraction stage. Then after solvent extraction, we now, after leaching, this is the quality of the material you get.
The copper this is the copper which is
copper
leached
sulfate,
from the
which is leached
from the ore,
and it is also extracted, solvent extracted. Now it is ready for taking it to the machine for electrowinning. We call it electrowinning, a type of electrolysis. Now this is the type of these are two electrolytic cells we are using here. Two electrolytic cells. We use copper plate as the cathode, and we use the aluminium steel plate as anode. That one now, from this machine, we are getting, this is a rectifier. We are getting 500 amps and 4 volts. It picks in 415 volts, and then that one is stepped up. The current is stepped up to 500. Voltage is stepped down to 4 volts from 415. Now when it is coming out here, we are harvesting 500 amps and 4 volts. This is the ones now. When we put
extracted copper, the extracted copper from the leaching is put into these 2 containers here. You'll see them, where we do electrolysis, and the copper is attracted to the copper cathode.
Cathode, yes.
Cathode, and this is where we will now manufacture our copper metal for sale.
Yeah.
So basically, it's a leaching process, and then you use electrolysis, which is to separate the copper from the other non-copper materials, and then you recover your copper. This plant presently can do 100 kilos per day, depending on the grade of the copper. If the grade of the copper is higher, like 20, 30, then you can even do 200 kilos. And we are going to expand this process so that we have more bins, more electrolysis processing. And they set up maybe another plant in near the raw materials. That is maybe Makindu. That is where Garnite is going to set up the second plant. This plant has been in existence and we want to refurbish it so that we can produce copper from here as the first testing ground. Then we'll now talk about putting another plant, either an electrolysis or a furnace. Blasting furnace, heat furnaces produce more copper per day, so that we can compare with this leaching and electrolysis process. Mr. Tumbo is an expert. He has done this for many years. He can talk for himself.
Yeah, now I think that is exactly what it is. We are doing what we call electrowinning.
You can show the output.
Yeah, this is now the way we set up our vessels here. We are using this as bus bars, and then connectors and everything else. We have stopped because we are doing a lot of mining so that we can bring in the material. But here, the process is very simple. You can see this is the copper ore. Copper ore,
From the mine.
yeah, you crush it, and then when you leach, you get this solution, copper sulfate, which is 120 grams of sulfuric acid and about 50 grams of copper metal. From this, we also make a bit of crystals, copper, hydrated copper,
Sold in the market.
which can be sold in the market. It's used in swimming pools, in horticulture, and all that. And then when you produce the granular copper, we now smelt it to this kind of billet. It's about 15 kilos of a billet.
That is quality of that. This quality
Yeah.
is 99%
Yeah,
copper.
copper. Right now, we have done now a modification so that we are not going to this type of the grains. Yeah, we are granular. We are now going to get metal straight from them. Then we used to have problem when we were using the lead anodes, but now we are using we call them DSA plates, and they are doing their best. Temperature here is about 60 degrees. We have a compressor which now mixes the solution so that it is in contact with the anodes, anode and the cathode all the time. And I think that is a thing. The only machine we use is that one.
The rectifier. This is the main machine.
Main machine.
It produces current to separate the copper.
Yeah, because the AC is coming in, and what we are getting out is DC.
DC current.
Direct current. Yeah. And that is the one now which does the job.
So whatever is attracted, copper attracted here, is sold together with the anode.
With the anode.
Because you cannot separate.
Yeah, with the cathode. Because it will be just plain metal. We cut our plates, our cathodes from this to this size. This is the size we are using. Yeah. So that we have two anodes, one cathode, so that this one is filling from that side, this one is filling from this side.
And we have said we can increase this setup to,
to about
4
6.
to 6, so that you have more production. And that is what we intend to do in Makindu.
Yeah.
Put more anodes and cathodes so that you have more copper extraction. And that will have to be backed up with the mining so that more material is brought from the mine.
And now the other thing is that this is the only plant in Kenya which makes this type of, so it is an innovation.
Very good.
It was an innovation, and it worked very well. So many people come around to see it when it is working. It's marvelous. So
currently, what it requires is just the cathodes and the anodes.
Yeah.
And the cables that bring the power.
Bring the power, yeah.
And then we are set off. We bring in the material, and it will require, of course, the chemicals for leaching the original position before you reach to the solution.
Yeah.
So the input is mainly here, and the leaching chemicals, which most of them have to be imported. One of them, the main one, from China. But in the end, we want to compare the leaching process with the furnace.
Furnace, yeah.
Furnace
will give out, you can easily get about 10 tons.
10 tons from 100 tons of copper.
But
that
that copper now will be 95%. So it requires further refining.
But it can be sold at 95.
At 95 we can sell it. And
95% copper.
Yeah.
And I think that's all.
That is
Our
all.
demonstration is brief. This is just
to the point.
A small setup, but it is working.
So next time you come around, it will be working. Then you now see the exact job being done. That is for water storage. That tank.
The big tank is for water storage. And these are for leaching.
For leaching and the solvent extraction. These ones are now the electrolytic cells.
And this small plant is situated in a river near Nairobi city. It is in an industrial, small-scale industrial setup. And we need to expand this mainly to another place, so that now the work can be more economic volume of production or scale.
Yeah.
So that's Mr. Tumbo. He's a man behind this. He's a chemist.
He's a chemical engineer.
Chemical engineer.
Yeah.
He'll be able to guide us through the process.
Yeah.
And through the process of electrolysis or copper furnace. I am the mining engineer. I'm more or less in the field, bringing quality copper.
Yeah, so my expertise, I've been in the industry for 40 years now. So I don't leave anything to chance. Normally it is just targeting, making sure what we are.
And you have sold copper locally in the past?
I've sold copper locally. It's fetching about 500 shillings per kilo.
500 shillings, about $6 per kilo?
Yeah, just about that.
That's locally?
Yes.
And the demand is very high. They come and pick the product here?
Here, just call them, they come and pick everything. And we are...
I think that is all. A short presentation. We would have done it if there was more time and space. We would be able to explain the process.
Yeah.
And from the mines.
The other thing is that this kind of plant, we can manufacture zinc using the same process and a few other metals. A few other metals like aluminium.
Aluminium. You can extract aluminium and zinc.
Zinc.
If you have the raw materials.
Yes. And nickel. Nickel. Yeah.
But how about the crystals? We intend also to come up with a project for crystals manufacture.
We need to come with a process when you look at this, because the crystals, they are also high ton, and this is the kind of machine.
This is a plant for crystal. This is another project. Apart from copper production, you produce crystals of copper sulfate, sodium hydroxide. This is another project that you use local materials. But this plant has to be purchased. It's quite an expensive plant. But we are thinking of the furnace, the electrolysis first, then the furnace, then the copper crystal production plant. Those will be like 3 projects.
Yeah, because the crystal line is important in the sense that we don't have people manufacturing crystals here.
Most of the crystals are imported.
And it is the minerals we have here, and the chemicals we have here.
So why not produce here and sell here?
When you get your liquid extract, like that one of copper sulfate, put it in this is a crystallizer, evaporator crystallizer, and you get your crystals out. That is all. You get the Magadi soda.
We will look for the technology in China, in America.
Yeah, wherever it is cheaper.
Wherever it's cheaper. It's a high turnover volume.
Yes. So we are aiming at industrializing quite a bit, so that we have the whole. It is economic for the country. We are value addition. We are doing value addition to the minerals, because once you export them when they are raw,
there is
they are rocks. There is no value. The value
price
is
very low.
Very low. But when you purify, then you make more money, get economically.
Okay.
The government, the people, everybody, the owners of the mines, they're also having.
The shareholders will benefit. People
yes.
put in money into the project.
Yes, yes. So I think that is all for today.